Good evening friends. Today we will discuss generator loss of excitation. So let's start from here. The generator is generating megawatt due to the work done at the shaft of turbine by this steam, and the generator is generating megawatt because of the field current or excitation. Now what will happen if this excitation is stripped or this field current is lost in the generator? Due to this field current, we are getting induced EMF. So if there is no field current, there will not be any induced EMF. So the EMF will start decaying. Step 2. If the EMF will start decaying, what is my power equation? P is equal to EV upon X sine delta. So if E is decaying, that means P will also start falling down. The active energy delivered will start falling down at the terminal of generator. Now if the active energy will fall down, the mechanical energy which is available at the shaft of generator, it will be converted into kinetic energy, and the generator rotor, it will start accelerating. Due to this acceleration, generator will experience a slip. Now the speed of generator is greater than the synchronous speed. Due to this slip, some eddy currents are induced in the rotor surface. Okay. Now this eddy currents will contribute for the magnetic field in the air gap of the generator. Now due to this magnetic field, an EMF is again generated at the stator winding. Now due to the EMF, the active power will again come back into picture. Now generator will act as induction generator where speed is greater than the synchronous speed. So simply I can say, if generator loses its excitation, it will act as an induction generator, and this is the intermediate process before becoming induction generator. So for induction generator, there are certain conditions which are very much essential. The condition number 1 is the grid should be strong enough. Why? Suppose the generator was delivering Q1 amount of megawatt. Now suddenly when excitation is stripped, instead of delivering, the generator is absorbing Q2 amount of megawatt for its excitation. So what is the net impact upon grid? It is Q1 plus Q2. So it may happen that the grid is running short of megawatt, and if grid is running short of megawatt, the voltage of the grid, it will start falling down. So the grid may collapse. So the very essential condition is the grid should be strong enough to feed megawatt. Number 2, the active energy should be within limit, that is 20 to 30% of rating. Why? The generator is taking excitation from the grid, so it is coming through the stator winding only. The excitation and the load current both are flowing in the stator winding, so the stator may damage if the level of current is high. So if we will reduce the active energy of the generator, the level of load stator current, it will also decrease, so we can protect our stator winding. So the second condition is also justified. Now the third condition, as I said, the generator is running more than its synchronous speed. So the slip should be within control. It should be between 0.1 to 0.2 percentage. If the generator is attaining high value of slip, that means there will be more d phi by dt across the rotor surface. So the rotor heating will take place. So these are the three conditions for stable operation of generator. And if these three conditions are not able to experience by the generator, then we have to immediately trip our generator in order to protect it. So in the next session, we will discuss generator loss of excitation protection, where I will discuss all the parameters of generator relay. Thank you and